Now let's get into the design part of this course where we're going to go through several different types of occlusal guard designs, starting with the easiest and working up to some of the harder designs. I think all occlusal guard designs are fairly straightforward and easy to master and implement within your practice with a little bit of practice. Let's start with what I would consider just a wear management or a typical night guard, where we're not going to build any guidance into this appliance. We're literally just going to design it with static occlusion, and then we're going to finish it and print it. So DentalDB is essentially our command center or our prescription center for using the exocad software. It's where we set up a case to tell exocad what type of wizard workflow and options we want to get within our design. So for this one, the first thing we need to do is set up our client. So in exocad, the client controls the saving of the standard settings. So any settings that you change within the DentalDB under a client name are saved under that client. So if you design for lots of different doctors, you probably have a different prescription set or parameter set for each one of those doctors. You would want to have a client for each one of those doctors. If you're in an office, either in an office lab or a lab where it's maybe a couple doctors and they all use the same settings, you can use one single client for that. But that's kind of the reason why you would want to have different clients. I'm just going to use default for me. For this case, let's call this night guard. The technician here, what that does is it tracks who does the designs for the cases. So this is helpful if you're in an office, you have multiple people designing, you're trying to track for bonus systems, you can run some analytics on that. If you're also trying to track for performance to see who's doing good designs and who's doing designs that maybe need a little bit of work, this can help you to do that as well. We don't really use that as much in the Mod Institute, but in Mod Restorative Studio, where we have lots of different people designing cases, we do use the technician tag so we can go back and see who designed cases. So the first thing we need to do here is click on a tooth on the upper arch, because we're going to design this appliance on the upper arch. Then we're going to get into the menu where we can select what module we want to do the design in. For this case, I'm going to do this in bite splint, obviously, right? Of the options that we have here, that one makes the most sense, and it's definitely the one that we'll use for all our bite splint designs. There are reasons that we're not going to get into this in this course where you would use bite splint to design other things like reduction guides, bleaching trays, retainers, different things like that. It's a really versatile module that can have a lot of different uses within your practice. I'm going to click splint resin. The big difference here between PMMA or splint resin is the tool compensation that will be applied to the bottom design. So essentially, if you're milling your splint, you know that you have a certain diameter of the tool that you can't mill anything smaller than that tip. So you have to design so that the bottom or the fitting surface of the appliance, it doesn't have any triangles or geometry that's smaller than the tip of that burr. In printing, we're really only constrained by the tip of the pixel size of the projector or the laser tip, depending on what type of printer you're using. So it's really not that big of a concern, and one of the reasons why the fit for printed appliances tends to be much better than the fit for a milled appliance. Once we get to the options and parameters menu here, we have a couple different options. If you wanted to copy or mirror a tooth, say if you had an edentulous space and you were trying to copy a Ponic into that space, you would use the copy mirror tool. It's not anything that I use with any regularity in my occlusal guard design workflow. For the next menu here for virtual extraction, we're not going to do a virtual extraction in this case, but if you had a case, say, where you knew you were going to extract teeth and you were trying to pre-design a guard, you could go ahead and digitally remove those teeth, so the guard would be pre-designed, printed, and ready to deliver after the extractions were done. Under the bite splint mode, we have a few different options here. The first option is standard, and that's essentially what you're going to use for almost all of your occlusal guard designs. Whether it's a single arch, dual arch, a deprogrammer style, anything that fits within kind of normal occlusal guard design workflows, you're going to use the standard. The fill gap for missing tooth, really all that does is it prevents the splint from being pulled all the way down to the tissue. It's not really something that I use that regularly within my design workflow, but it is an option there. The anatomical use anatomy from Tooth Library, what this option is if you're someone whose philosophy is that you like to use a removable appliance to test new vertical or occlusal schemes before going to a full mouth rehabilitation, you can design a splint that is based on a wax up over top of the teeth, so it would have all of your new vertical and guidance scheme built into that appliance, and then you would be able to overlay that, deliver it so that it fits on the patient's current teeth, and you could have them wear it for whatever period of time fits your philosophy for doing a full mouth rehab and having a patient acclimate to some type of new bite. It's not something that I personally believe in. It's not something that's really that well supported in the literature as far as the necessity to do that. But if you want to do that, that is the module that you would use to do that. For minimal thickness, we always are going to leave this at 0.3 millimeters, and what that assures is that we can taper the border of the appliance down to a fairly thin margin. It'll be comfortable for the patient. They won't have any issues with their tongue, but it is also going to be a thickness that we can print relatively predictably on any appliance. The blockout angle, what that does is it controls the angle at which undercuts are going to be blocked out within your bottom design. So 0 degrees essentially means we're just blocking it out straight up. If you want to make that more obtuse, essentially it's going to block out so that there's more wax. The wax is going to, flare outwards and give you more draw on the appliance and less undercut engagement. It's not really something that I'm ever changing within any type of occlusal guard design for myself, because what you run the risk of is making the appliance too loose so that it's not retentive because you've got the blockout angle too wide. The peripheral thickness we like to use as 1 millimeter. What that does is our initial proposal is going to have 1 millimeter of thickness around the periphery of the appliance. We don't really need to do a lot of adjusting in the freeforming of an appliance with that thickness. It's going to be thick enough to provide rigidity and support and not break, but thin enough that it will be comfortable for the patient and not provide any type of overly bulked areas down on the peripheral of the appliance. The occlusal thickness is something where you may want to adjust at different points. You can see that the last time that we designed on this computer, we were probably designing like a reduction guide or a bleaching tray or something like that, because the occlusal thickness is dragged down to 1 millimeter. In reality, we want all printed occlusal appliances to be ideally at 2.5 millimeters thick, which is the default in exocad. If you have issues mostly with lip competence where a patient can't close over a thicker vertical, you can cheat down to 2 millimeters of thickness, but below 2 millimeters you're really running a major risk of fracture of the appliance because it's just not thick enough to support the occlusal forces. This case was opened up well enough for us to do 2.5 millimeters, which is the ideal. So I'm going to go ahead and leave that at 2.5 millimeters. The bite splint top smoothing, what this does is it determines in the initial proposal of the bite splint how smooth out it's going to be or how aggressively it's going to follow the occlusal anatomy. We usually just leave this at the default of 3 millimeters if we're designing an occlusal guard, and that tends to work really well to get us a nice initial proposal that we can freeform and get to an area rather quickly that we'd be comfortable going to a final merge design being ready to print. Under the advanced parameters, really the only thing we have control of here is the milling diameter or the milling compensation. This is what we talked about where we're talking about the differences between printing or milling, looking at tool diameter, the tip diameter versus light source and the size of the pixel size of the projector, the laser tip size, those types of things. The safe amount to use for milling diameter compensation for a printed appliance is going to be 0.2 millimeters. That's safe on any printer on the market to give you predictable fit. In practice, I haven't found that it matters that much if you leave it at 0.1 or 0.2 for the triangle size and the milling compensation if you're printing. After we click OK, we get the option to choose a single arch upper appliance or a single arch appliance or an upper and a lower appliance, a dual arch appliance. For this case, we're going to do a single arch appliance. In some of the next cases that we'll work through together, we're going to do some dual arch appliances, and you'll see how that changes the workflow a little bit. All right, so exocad, when you come back to this screen, it has auto-enforced every tooth to be selected in the arch that you're going to be designing the appliance on. This is critical if you're using the AI tooth segmentation feature that's now available in the new 3.3 Byte appliance design, because if you have teeth selected here that aren't actually part of the arch, like say if some premolars are extracted, the software is still going to try to go in and auto segment out those teeth. You can correct it once you get into the software, but it's much better just to set the case up correctly so you don't have to correct it when you get into the software. This case has second molar to second molar, so we'd be fine to leave the case just like this and go ahead and move into the design from here. So the last thing we need to do is we need to go ahead and click Save, and we're going to click Design. Once we get into design, the first step is always going to be to bring in our jaw scans. So we're going to go in and we're going to find case number 1, which is going to be our flat plane. We're going to bring in our upper jaw first. It tells you right here, upper jaw in this upper left-hand corner of the window. It's also, the other way to think about it is the arch that you're designing on. If you're doing a single arch case, is always going to be the first arch that gets brought in. We're going to then bring in our lower jaw. And so now we have both of our arches in place. The first step in exocad, and one that's critically important, is setting our jaw scan data orientation. This essentially is telling the software what's up and what's down. If you look here, the software tells you right here in the corner what to do. We don't want to be looking inside the mesh where it's red like this, because then everything's going to come in upside down. We're going to have a lot of problems when we get into design. All right, so now we have our jaw scan orientation set. So we're looking straight down the upper arch. We're going to click Next. And this is the part where the AI-driven the tooth segmentation is going to happen, which we'll use to help detect where the border will be in the next step of the design. So now you're just going to let it run. It usually takes about 20 or 30 seconds to segment out all the teeth. And then all we do is hit Next. All right, so the AI tooth segmentation is finished, and now you'll see that all our teeth are different, multicolored. You can go in and just check the borders to make sure that the cervical margins are detected pretty well. And yeah, it looks like the AI did a really good job for this case. The other thing, which is not really important at this stage, is you can see essentially the long axis of the tooth for how the software is predicting that to be. For a bite splint, it makes no difference if the long axis is correct or not. If this was a denture case, then we would want to go in and check and make sure that the long axis was correct for how we wanted the neck of the tooth to be generated. Because when you flip underneath, right, like the long axis is determining what this neck of the tooth is going to be generated like. Everything looks good to me at this step, so we're just going to go ahead and click Next. All right, now we're in the bite splint bottom design. And so what this is determining what the virtual wax up model is going to be like so that we know how the appliance is going to fit to this arch. So when the appliance is generated, it's not going to fit the regular scan, it's going to fit the virtual wax up bottom, which has undercut block out, smoothing applied, an offset applied, so that we know that there's going to have good draw and good fit of the appliance. If you try to design this just on a regular scan, you most likely have issues because of some of the occlusal anatomy needing to be smooth, undercuts being a little bit too much as well. So at this step, we have several different options here for making adjustments to the virtual wax up bottom. The first is the blockout undercuts tab. And so there's a couple different options here. The first is the offset. So the offset is essentially the wax spacer. So it's essentially what wax is going to be applied over the entire model before we go ahead and start the design of the appliance. 30 microns tends to be very predictable. That's what I use as my standard for any occlusal appliance that I'm designing. I don't ever change that. I tend to prefer the thermoplastic 3D printed occlusal resins for my occlusal appliances like NightGuard Flex, NightGuard Flex 2, KeySplint Soft. I don't use KeySplint Hard, NightGuard Firm, any of the non-thermoplastic materials. If you like to design and print with those appliances, you may want to consider increasing the offset here, maybe to like 50 to 75 microns to give yourself a little bit more space and prevent the risk that you're going to have an issue at delivery. But for any of the thermoplastic resins, the 30 micron works really well. The blockout angle for the undercuts at 0 degrees, we already talked about that. I also don't change that for anything. If I was looking at the allowed undercuts, this is the other area where I consider making adjustments if I was using a non-thermoplastic resin. And 100 microns for thermoplastic resins tends to work really well for having an appliance that is retentive, but one that you typically have no issues at delivery, and your delivery should really be 5 minutes or less for most of the appliances. If you're doing one of the non-thermoplastic resins, then you would want to take this down to probably like 50 to 75 microns of allowed undercut, so 0.05 or 0.075. Under the bite splint properties, we have a couple different options here, but none that I really make any changes. The smoothing determines how smooth the proposal for the bite splint bottom is. 17 to 20% tends to be really predictable so that the model will be smooth enough so that you don't have issues with generation and merging, but not so smooth that it's going to be something that's just flopping around on the arch because there's too much blockout. The minimum thickness at 0.3, we talked about that in the standard settings setup, and then the milling diameter compensation, we also talked about that as one of the advanced settings in the initial setup. When you set these settings up in the initial case setup in the Dental DB, they're always remembered and applied the next time you come in. If you were to adjust one of those settings in this menu, it would only be for this specific design and it would not be applied to the standard settings under that client. So the last thing we're going to do here is determine what our insertion path looks like. And so for me, the insertion path here is actually rather good. I don't know that I would change it. There's a nice split between buccal and palatal coverage. You know, it looks really good. What I'm checking for on the buccal is that I don't have a lot of wax past the height of contour. Once we move posterior, we have some, and that tends to always be the case just because of the change of angulation of the teeth back there. The other thing to notice here is particularly on this number 2, this patient has blockout that's applied essentially circumferentially around this back side of this tooth. What does that mean? If we draw our border appliance over this, there will be space between that tooth and the appliance when you go to deliver it. It doesn't mean that 3D printing is not good or inaccurate. It doesn't mean that digital design is not good or inaccurate. It means that we need that amount of block out there to be able to deliver this appliance predictably. If you have a patient who complains that there's space back there and they can get their tongue, and I've done enough of these that it's happened to me once or twice, just go ahead and remake the appliance and then just design the border on the tissue. If you design the border on the tissue, you can see that there's no block out there. So we know that's going to fit tightly up against the tissue, and the patient won't be able to get their tongue underneath it. Everything at this stage is now set, so I'm going to go ahead and click Next. It's going to generate the virtual wax up bottom, so it's going to apply the offset, the allowed undercut calculation, the smoothing of the model. And so now it's going to give us, let's just turn on the virtual wax up bottom so you guys can see. It gives us this model, right, where we have our blackout wax. We have a distances menu that tells us, you know, how much wax is applied here, like how much undercuts are allowed or not. You can go in and adjust that, and we'll talk about reasons why we would want to do that in one of the deprogrammer cases. The other thing that happens here is we have the border pre-drawn for us, and this is simply based on the AI tooth segmentation. I'm going to turn the bottom back off and just back to the regular scan so you can see. And so the cool thing is there's lots of different margin detection parameters that we can go in and delete and get any type of margin that we would like. I used to tend to draw my margins really flat and smooth, but I found that this slightly scalloped design tends to work really well for most patients also. So there's really not a lot of reasons to change this here. One thing you do want to check if you are going to use the AI for the margin detection is sometimes these interdental balls will be driven all the way through the interproximal contacts like this. This will cause a problem when you try to finish this design and merge it. You want to make sure that they don't go too far interproximal and that you don't get overlap between the buccal and the palatal surfaces of the design. The other options you have here, like say we wanted to change this, we just wanted buccal and lingual surfaces. The first thing you want to do is just delete what you have, and then you click Detect Margin, and it's going to redraw the margin for that appliance. This is also completely acceptable. I like that we have nice coverage, buccal and lingual on this design. But you have a lot of different options to choose from here. You can determine like which one you prefer, and you can go ahead and start to use that for. The other cool thing is if you select it and hover your mouse over it, it gives you an idea of what the design actually would look like. So just go in and play with those options and see which one you like, and you can just go forward with that. Under the surface properties, we have a couple different options here. We have our occlusal thickness, which we set in the standard settings like we talked about in the bottom settings. Here, if you make adjustments to the occlusal thickness, it will not be enforced as a default setting for that client. It will only be enforced for the design of this particular appliance. The peripheral thickness we have at 1 millimeter. The smoothing we have at 3 millimeters. So that I'm all just going to be leaving the same because we set that up in the initial part of the case. The other option here, and we'll look at this when we design the palatally supported deprogrammer. If you want to design the border of your appliance on the palatal tissue, you need to click Include Palette. Otherwise, you get an issue with the generation of the bite splint top because the software is having issues determining where the tissue is based on the bite splint bottom. So everything looks good here to me. I'm going to go ahead and click Next. And so now we have our initial proposal. And you can see I have occlusion pretty much consistently across the posterior of the appliance. If you take your bite record at the right opening, then you usually are going to get occlusal thickness. I'm a little heavy here, but we'll go in and smooth that out and adjust that. But we need to pick up our occlusal contacts anteriorly, right? So the first thing I'm going to do here is I'm going to take my strength and I'm going to drag it all the way up. I'm going to take my size and I'm going to drag it all the way up. And then I'm going to go in and use the tools that we have here. And so let's spend a couple minutes just talking about that. So you have different action tools that are available in the freeform bite splint top. The first is Add Remove. And so the left click when you have this highlighted orange is always going to be the Add tool. The Shift and left click is going to be the Remove tool. The same thing for Smooth Flatten. The smooth tool is going to be the left click. The flatten tool is going to be the shift and left click. And so the differences between smooth and flatten is essentially smooth tries to find the median of the circle between the highs and the lows, the selection circle that you have defined, and it's going to bring things up to the median. The flattened surface is just going to bring things down towards the minimum of the geometry within the circle. So the flatten tends to be a little bit more aggressive, and that's what I want to use here. I want to get the posterior part of this appliance nice and flattened out. The next thing I'm going to do is go in and use my add remove tools. I'm going to add until I start to get occlusal contacts. I'm less concerned here about the color mapping and more concerned just getting contacts. Now the last thing I'm going to do here is I'm going to take my size down to about the H in the shift. I'm going to make sure I have add remove selected, and I'm going to come in, and then in front of my occlusal marks anteriorly I'm going to remove some to make sure we have some freedom and I'm not going to get locked in here with these occlusal contacts. I'm going to switch back to smooth. I'm also going to go in here to add remove, and I'm going to make these contact marks a little smaller. It's a little bit big for me. And so now the last thing we need to do is we need to adapt the occlusal contacts to the even strength. So essentially you can think about this as equilibrating everything to the exact occlusal strength that we want, so it's even across the arch. And so the way we do that is we go into adapt, and then we're just going to click the static occlusion adaptation. You have control here whether you want to cut space or leave overlap. And for a bite guard or a night guard type design where we're just trying to protect against wear, we're not really trying to do any type of treatment. We just want to go ahead and get our occlusal contacts equilibrated everywhere at 0 so that there's no overlap, but they're perfectly touching. All we need to do is click static occlusion. It's going to equilibrate out all these contact points so that they're the same color mapping. We're going to have a look, and that's it. We're just going to click next. The software is going to go in and merge the appliance, and now the appliance is merged and it's ready to take over to our printer to print. So now you guys have finished up your first design of just a typical static occlusion night guard design where we just flattened the posterior and made sure that we had nice even occlusal contacts everywhere throughout the appliance. The next one we're going to go into is we're going to talk about some dynamic equilibration where we have an articulator set up and we're looking at making dynamic occlusal adjustments and building in actual guidance to the appliance. All right, so now that we've finished our night guard design, what we need to do now is we need to look at how we would get these files out to nest them in our printer, right? And so within the scene right here, you see that we have the merged part, or the part that is adapted to the scan. We can save this directly out of this scene on our desktop, and this is probably how I'd recommend for most of you if you're going to be designing in your office, and putting a folder on the desktop so your team knows to go in and print those. Right click into space, you can click Save Scene As. We want to change this to an STL file type. STL file types are the file types that the printing slicer softwares are going to read. You can go onto your desktop and we can call this Bite Splint and then save it right there on the desktop. Visible objects only, yes. Default coordinate system. You want to make sure when you're saving your files out like this that you have everything turned off. You know how it said visible objects only? If we had all this other stuff turned on, it's going to export all those files as one file out of this CAD scene. The other thing that you'll notice is in your Dental DB, if you click Open in Explorer with the project open, it has the Bite Splint CAD, which is the merged Bite Splint, in the CAD folder for this project. And so that's your CAD data folder. It usually is going to be on your C drive unless you're specifying for it to be somewhere else. That is how we would save the files out so we could go in and nest them in our slicing software and 3D print them. And we'll look at how to do that a little bit later in this course and some tips and tricks around that.